Welcome. This is going to be our solving quadratic equations by completing the square video. And in this video, we're going to use a technique where we are going to create these perfect square trinomials, meaning a trinomial that can be factored into two binomials that are equal to each other, thereby making it a binomial squared. And we'll use that to help solve. Now, our first question is question number 1 from worksheet, which is p squared plus 14p minus 38 equals 0. Now, some might say, why not use a quadratic formula? Which, interesting, is a good question, but the quadratic formula actually comes from completing the square. There are certain advantages with completing the square that quadratic formula, it may not necessarily be helpful with. The first advantage in this case is that technique involved. There are steps by steps we can follow that are relatively straightforward, and the probability of making error is a lot less than plugging numbers into a formula. Because of the formula, you have to remember putting the correct signs for correct numbers and all the calculations, and making an error in one place makes the whole thing incorrect, though. Okay. Secondly, there's no place to kind of check your work when using the quadratic formula. When completing the square, we can do that, though. So let's take a look at the steps involved. Completing the square, we move the c term over to the other side of the equation. Divide the b term by 2, and then square that value. Put that number into the blank spaces. Now we go put blank spaces. You'll see why we talk about blank spaces as I do this, though. So the first thing to do is if we have this equal to 0, we move the constant over to the right side. Then, and in this case, replace it with a blank space on the. But if we go, that's what we'll add to both sides of the equation. You'll see how that works out there. All right. Factor the quadratic expression, meaning first divide the b term, the number multiplying the x by itself, divide by 2, and then square that. And that value, after you divide by 2 and square it, is what you put in the blank space. We'll factor expression on the left side and combine the values on the right side of the equation. Take the square of both sides and then solve for x. And remember, there's always two roots for a quadratic equation, one positive, one negative. And you'll see in this case the use of that plus or minus symbol. Let's see this work in action. So, with p squared plus 14p minus 38, we're going to add 38 to both sides. So now we have p squared plus 14p plus blank, that's the blank space talking about, equals 38 plus blank. Now the b value here is 14, positive 14 in this case. So we'll take b over 2, which is equal to 14 over 2, and then we get 7. We'll then take that number 7 and square it to get a value of 49. That 49 will go into the blank spaces on the left side and the right side. Okay, so we move the c term over, the 38 over to the right side. We had created spaces to be added to both sides of the equation. We found the number by taking the b term, dividing by 2, squaring it, and then we plug that into our spaces. We're now going to factor this. Now, some of you might say, but I'm not so great about factoring. But the great thing about this is, when we factor, well, it's going to be p times p, because p squared. But the number we found, the b over 2, this is the number that goes into this, both the spaces on the right. And it's plus 7, so it's positive 7 means plus 7 here. So in case you weren't sure how to factor, now definitely two numbers that multiply 49 add to 14 are 7 and 7, and you would have gotten this to be factored anyway. Okay, but in case you get stuck, that's really what it comes down to. We're now going to combine these two. 38 plus 49, that should give us a value of, it looks like 87. Right? 87, which means in this case, we now have p plus 7 squared. Okay, so that's what we meant by, rewriting this as the same term, same binomial squared. That's a perfect square trinomial, being able to write as a binomial squared. Our next step would be to take the square root of both sides, and the square root of p plus 7 squared will be p plus 7. And in this case, we're going to get equals to the square root of 87. But however, plus or minus, that symbol really means that there's really two answers there, because we always get two roots when in this quadratic equation. We have plus or minus. Now, square root of 87, well, I know that we can divide 87 by 3. We divide 87 by 3, I think we get, let's see now, 20, I think 29, which is not a perfect square, okay? And not as 3, I don't think we simplify it further. So we can leave that as is. Now we subtract 7 both sides. And so we're going to get p is equal to negative 7 plus or minus the square root of 87. Now that really means that the two roots are negative 7 plus the square root of 87, and p equals negative 7 minus square root of 87. I like putting that number that we are kind of getting away from p in the front and having that plus or minus symbol afterwards with the radical. This is going to be our solution for question number 1. Now, some might say, well, that's a lot of work, but the work is, in this case, pretty straightforward, definitely within our ability, and we can see whether or not we made an error in our work, which is why I prefer completing the square over quadratic formula. Let's try another problem. Question number 9. In this case, we have r squared minus 4r minus 91 equals 7. Well, here's the thing. We don't need to subtract 7 and move it over. We're going to move over to 91 anyway, to move the c term over. So we're going to add 91 to both sides. So completing the square, we do this here. We're going to get r squared minus 4r plus blank equals 98 plus blank. And again, our b term, our b value is negative 4. That's this number here. Yes, we included the sign in this case, okay? So we're going to take the b over 2. Now b over 2 is negative 4 over 2, which is negative 2. And now we take the negative 2 and square it. That gives us a positive 4. And this 4 is going to end up going into the blank spaces. Okay? Again, all we're doing is taking the b value, divide by 2, and squaring it. Now, some of you are thinking, what happens if there's a odd number? That's okay, because we'll still have the same procedure, right? So we factor, and we end up getting r times r is r squared. And remember we said before that this b over 2 is a number that plugs into the end. So we're going to get, in this case, negative 2 and negative 2. So even the factoring part should not be discouraging us from actually solving this. Now 98 plus 4 is 102. Okay, all right, so this now becomes r minus 2 squared equals 102. We're going to take the square root of both sides, and now we get r minus 2 equals plus or minus, don't forget that's the one thing you have to keep remember, plus or minus symbol, 102. Now, we want to figure out in this case, can 102 be simplified? And the answer is no, right? There's no perfect square divides evenly into 102. So now we'll solve by adding 2 to both sides, and we're going to get r is equal to 2 plus or minus the square root of 1 over 2, which means in this case r equals 2 plus square root of 102, and r equals 2 minus square root of 102. Okay. Let's do one more. Question number 16. And this one, we're going to have to move some things a little bit around. We definitely want to move the 12x to the left side, so adding 12x to both sides. We're also going to get rid of the 48, so add 48 to both sides. So we're going to get, in this case, 6x squared plus 12x plus blank is equal to 48 plus blank. Now, before we continue, one of the things I recognize is that we can divide everything by 6. And now, why is that a good thing? Because the smaller numbers we have, the easier. And not only that, we always want to work from 1x squared. It makes things much easier for us. Even if it means, in this case, that we're going to end up with a fraction. That's totally okay, though. We want to keep everything to 1x squared. So we have x squared plus 2x plus blank. And 48 divided by 6 is equal to 8 plus blank. Now we take our b term, which in this case is 2. So b over 2 equals 2 over 2, which is equal to 1. And of course, 1 squared is just 1. And so we can add 1 to both sides here. This now ends up becoming, factoring left side, x and x, we see a positive 1 here, so plus 1, and we see the factor same thing. On the right side, 9. We have x plus 1 squared is equal to 9. We will take the square root of both sides, and we end up getting x plus 1 is equal to plus or minus 3. So when we solve this, x plus 1 equals plus or minus 3, we're subtracting 1 by both sides. Yes, and this looks very complicated looking, but let's take a look here. X is equal to negative 1 plus or minus 3. Well, in this case, we have x equals negative 1 plus 3, and x equals negative 1 minus 3. Well, that would mean x equals 2 or x equals negative 4. And we see no radicals. Everything works out nicely. So completing the square works for even situations where we can factor. Okay? All right, everybody. I hope this was helpful. Watch out for our next video when we're using completing the square to find the vertex form of a quadratic function. All right. If you found this video helpful, please give it a like, subscribe to the channel. If you have not done so already, turn notifications to be alerted when new videos are added to the channel, and leave any questions or comments in the comments section below. Thanks for watching, everybody, and look forward to seeing you in the next video. Take care. Be safe.